Yeah, hey, welcome everyone. I'm happy to present today's episode to you. I think it was a fantastic idea from Andrea. It was not my idea to talk about curiosity, but I think I like that. I love it really. And I'm happy also to have all those guests with me today. So unlikely as last episodes, you remember how we usually work. It's a slightly different thing today because we really want to talk, and you're also invited to bring in your questions and ask your questions whenever you think it's appropriate. So it's not a monologue here from anyone. It's really, we really wish to have it interactive. So a short thing about how it works technically is you can see there's a navigation bar you can use. There's a Q&A section for the questions where you can post your questions. I will check in, we'll see what's happening there, can see what kind of questions you have. And from time to time, I will also ask the panelists the questions. So feel free to ask your stuff, and don't be afraid because there's no silly question, right? It's just the silliest thing to do, not to ask questions. But hey, that's why we are here. So today's topic, as you've seen, it's all about curiosity. And so that made me curious, of course. I'm personally, I'm a highly curious person. And I was really unaware of what curiosity really means as a word. And I had to look it up because it really means a strong desire to know or learn something. So there are a lot of statements in there, which we probably have to discuss today with our panelists. And I welcome today from left to right, it's just my order in the gallery. Tobias Krafft, welcome. Uszkoreit, welcome. Andreas Becks, welcome. And my famous Andrea. Welcome as well.
Thank you, Steffen.
Since it was not the first and last time we do that kind of films, happy to have you as a moderator as well. So we both will lead through this, no, it's not really evening, but slightly evening, and with the first questions. So welcome everyone, and I just would like to take the floor, Andrea, and ask the first question. Introduce us to our panelists, please.
Thank you for the very kind introduction, Steffen. Yeah, I had the idea to talk about curiosity and artificial intelligence because we at SAS, we were asked to be curious from our marketing department, I think 12 or 15 months ago. And I asked myself, how can we connect curiosity with artificial intelligence algorithms? So I think, or I had the idea that maybe those algorithms, which are designed to give standardizations and automations, that they may kill curiosity, that this is something like there's something like a controversy, and so I had the idea to ask some experts what their views are about. And the first expert is my dear colleague Andreas Becks. He leads a team of AI experts at SAS. He is dealing with data governance professionals and data scientists, and he is advising his clients on how to use analytics. His main focus is on data-based innovation and industrialization of analytics. So with other words, also he deals with artificial intelligence. He has a profound expertise in AI and deep knowledge of business intelligence and analytics mean that he is well placed to help to reimagine business models and drive cultural change. You can see I have to read this from my paper because he's a very complex person. I can't remember what he's doing. Thus, we are happy to have Andreas with us to further discuss if AI kills curiosity.
My pleasure being here.
One thing before you start, because you're both from SAS, one thing. So if you have to show curiosity, will your salary depend on that?
Yeah, maybe. So, but I think that SAS attracts curious people per se, because of course what we do is we work with data, and you find data either boring or you love it somehow. And when you love it, you would like to gain understanding and get a deeper understanding of what the data tells you. So if you're not curious, you're probably not going to work for SAS, right?
It's true. I can confirm.
Okay.
Okay, and the second guest I have invited is Tobias Krafft. He has a PhD student, or he is a PhD student at the Chair Algorithm Accountability of Professor Katharina Zweig. I think maybe some people know about her. And he is at the Technical University in Kaiserslautern. Is this the correct translation into English? And Managing Director of Trusted AI GmbH. This is a very German description of a company. He is an expert in black box analysis and regulatory approaches of algorithmic decision systems. Besides, he is head of the working group Ethics, Responsible AI of the AI Standardization Roadmap. And maybe he will dive a little bit deeper into this topic in our further discussion. And I have to add, sorry, I don't want to forget about that. He holds the Weizenbaum Award of the Forum for Computer Science for Peace and Social Responsibility. So happy to have you with us, Tobias.
I'm also happy to be here.
Tobias, so if black box is on your agenda, you have to be curious, right? Because black box is like, what's in it?
Definitely. We have so many computer systems all around our heads today. We have computers, we have technical systems in the societal usage, we have smartphones all using, and all in all of these areas, we are using computer systems as a black box. We give some input and hope to get the right output. But if it's even the right point or the right time, we're not sure about.
I love the word hope here. One thing, because as you said, Katharina Zweig, so she's actually a co-founder, right?
Yes.
Of your think tank. And I got to know her because of the Ankut commission of the German Bundestag. So she is also, or you have been also heavily involved in creating the AI strategy of discussion around AI in Germany, right?
Yes, we are happy to create the first risk-based approach for artificial intelligence here in Kaiserslautern and talk to the politicians here in Germany, and are happy that they use our approach in the national and international regulatory approaches in the AI Act here, which is hopefully coming in the next year on European level.
Interesting. So Katharina Zweig is very engaged on Twitter. Are you on Twitter as well?
Yes.
Okay, so people can connect on LinkedIn and on Twitter with you.
And this is not a black box.
Right.
Maybe the outcome.
Yeah, let's see what Elon Musk is doing. Good. Yeah, and of course we have a third Hans who joined us as well. I got to know Hans actually via the EY Academy part and EY podcast recently, which was a pleasure just to meet together. And it was interesting because of your base background and what you have been doing as a founder and a chief scientist of, let's say, the startup and also the German AI Institute, Research Institute. The startup's name is Giants, where you have been, or where you are the chief scientist and doing heavily work on natural language processing as well. And of course, as a scientific director of the German Research Center for Artificial Intelligence, you are at the very front of what's happening. And I personally, when I was listening to your speech at the podcast, and I just bring the people here who joined us in the same picture as I have. You have been so long in China, right? There's so much experience on many levels. How long have you been in China, or are you still traveling to China?
No, I'm back now, but I've been in China only 3 years, but I also spent quite a while in the United States and then all the rest in Germany.
Yeah, I think for me it's interesting because it might bring in some different perspective on our subject today, curiosity, and given an international context. So if as you can oversee much more research and what's happening there, it's quite interesting.
Yes.
Just to summarize all the people we have here just in the gallery for a second. So we have different expertise, as you've heard. So Hans is really research and academics and doing startup. He's a startup guy. So hey, startups. And, and Alexander, he's a deep expertise from the industry as well. So bringing back more of the economic side of the company's perspective on the subject, which is quite interesting. And Tobias, of course, is also the expert on the ethical part and how algorithms work. I think there's a huge power team here with different aspects on how to work on curiosity. That brings us to the first questions. Andrea.
Yes, the first question would go to Tobias. When you think about artificial intelligence and about the process which you would like to standardize with artificial intelligence, at which point do you think starts curiosity? Don't we have to consider two aspects there when the algorithms being developed and after, when the algorithms have processed any results, then to think how we can use those results, which requires much curiosity or curious behaviors from us as human beings?
You're absolutely right. When you asked me to attend this panel, it was my first idea. When we talk about artificial intelligence, we only see the decision-making system at the end. For example, for a classification of pictures or objects or the scoring. But dealing with data science has a lot to do with curiosity. We can understand situations even better if we look at the data we are gathering there or producing. We can better understand problems and perhaps find better solutions only by digging deeper into the data. And we can use data on an ethical way. Perhaps we can use statistics to educate human decision makers about potential unfair or perhaps discriminatory decisions, because we are showing them how they have been decided in the past.
Mm. And Andreas, what do you think about those two aspects? How do you deal with this important aspect of curiosity as an algorithm manufacturer?
Yeah, so first for me, what is curiosity? And like Steffen, it's not easy to tell what's behind that word, right? So the German word Neugier is somehow negatively connotated, right? Because it is, you want to be in things all the time. But I think that's a positive thing, right? You are driven to ask the right questions. You want to explore all the information. You ask the what ifs, and this is one part really of also of AI, because AI can be a tool that can help asking the right questions and finding answers as well. So there are two aspects. One is the inside aspects of AI, right? Asking the right questions that really move something forward, like in medicine, how can we better diagnose skin cancer by including more reference data? So not a single doctor has seen so much data that he can really use that for his diagnosis, but AI could. Or my personal industry is insurance. So I work in the insurance industry, and the insurance industry is moving away from just understanding the risks they need to insure. They want to prevent claims by predicting and preventing damages. So they try to learn, how can I use telematics data or other data, more open data sources here to better understand those risks. Or look at the transportation or the aviation world. How can we keep planes on time and optimize routes from the touchdown to the gate, right? So all these are interesting questions fueled by data, fueled by curiosity. And I think very, very closely to curiosity is the capability. So there's no use in being curious if you don't have the capability to answer those questions, to approach those questions. So you need to have some kind of education, whether it's a scientific or philosophical education. You need to have some capabilities. And looking at AI, it's data and it's tools that can determine patterns in that data. And these tools need to be accessible to many people out there so that they can drive those insights, right? That's one part. So algorithms, AI can really be tools to drive curiosity. And the other part, you refer to that, and that's the automation thing. Let's look at the insurance industry again. So all industries are trying to automate processes, and the difference to the Industrial Revolution, where you automated a lot of labor, right? It's you automate intellectual tasks, and insurance industry is very much an intellectual thing. You don't craft something, it's a purely intellectual business. And if you look, for example, at the claims processing part, that's an interesting part. So you have a damage, Andrea, maybe you damaged your car. You hand in this as a claim to the insurer, and then the insurer needs to check how to deal with that. And that can be a very interesting task, but of course an insurance company wants to do that very, very fast. So what are they doing? They try to automate this process. And now you can ask the question, does it really make the job of a claims handler more boring or more interesting? And I think it's somehow the latter. It makes it more interesting because, of course, it's really not easy, but it's really doable to automate the claims processing part in terms of, so what's the severity of the claim? How much will it cost to repair your car? What is maybe the probability that you try to do fraud and betray somehow the insurer? That can be done automatically. But then what remains is a set of more interesting tasks. So the easy tasks, they can be automated. And we have made a project with one insurer who automated the claims process here. And the result was that the process as such was much faster than before. But what remained were tasks where the claims handler said that they are the more interesting tasks, because I have to look at all the pictures, I have to talk to the garage, I have to figure out how to deal with Andrea because she's a very complicated person, and maybe she will send the lawyer to me. So how can I deal with that? So tasks can get more interesting. So you reduce the complexity, the cognitive overload, by taking away all those simple tasks with automation, and the more interesting tasks, they can remain. So this is one practical example where AI didn't kill curiosity, but really helped to be more curious and reduce cognitive overload somehow. So I think that's an interesting observation. Of course, in future, that may change as well. So also the more interesting tasks can be automated. But that's then also a matter of how you design those processes. What do you want to have as an insurer? I do want to have people who are ready to talk to my clients, right? And they need to be curious, they need to be engaged. So that changes the profile somehow.
You have been right, but you said so curiosity has two sides. So one thing is to say curiosity is part of AI itself by learning things. And the second thing is just it's curiosity because it frees us, as the tech frees us.
Yes.
More interesting work. Okay. Hans, so coming back to you, so from you're a maker, yeah, you're actually building such systems as well. So what do you think, what could the role be of curiosity inside of the AI system itself?
Yeah, I think some of the keywords were already mentioned. First of all, it's twofold curiosity as an instinct. So there is the drive part and the behavior part. All we can model is the behavior part because we don't have a computer with a limbic system, yeah, that rewards with dopamine or something. So, but anyway, it doesn't matter. The same with emotions. We can only model the behavior, not the emotion itself. But that can be important. And I see three areas in which it is done and three areas in which I think it will be promising in the future. The three areas in which it is already done in a way, a little bit of it. One of them is active learning. So those are computer systems that ask for data in certain situations where, for instance, labeled data are needed in order to make decisions more secure, more certain, or there's conflicting labeling, missing labeling, or there are data missing. So in machine translation, an active learning system asks for translation examples for kind of expressions and sentences combinations it has never seen before in the data. So this is already one way of curiosity, asking for additional data. Yeah, so that's one way. A second area in curiosity is systems that try to acquire, not that are driven, programmed by people, but that try to acquire more knowledge. An example is NELS, the never-ending learning system at CMU, a system that day and night searches for new pieces of knowledge it can connect somehow to the knowledge it has already learned. If it cannot be connected, then it's lying around separately, but the system tries to connect as much as possible. And that's the knowledge building part. And the third part is actually exemplified, and that was mentioned already by you before. Namely amplifying human intelligence. Very often AI is used to amplify human intelligence instead of, so in addition to bringing in completely new ways of intelligence. And actually what we are doing, we are collecting from all over the world news that companies may want to have, things about changes in the corporate world. They want to know what their competitors, their suppliers, their partners, their subsidiaries, the regulators do. So what we are doing is we have kind of a search, a way, first of all, a very rough search that says maybe those phrases, words, mentions, names could be interesting. And then we go deeply in and search for the real interest that the human has. Namely, is it on financial, on compliance issues, and we have about 100 topics so far, 100 topics for which we search. And then we help human intelligence by searching, And but in the future, should I say it now or later? Oh, why not now? For the future, I foresee also three areas I can see many more, but just 3 areas would be of interest. One way of active showing curiosity in finding data is not the system that's connected to the internet, because that will filter. That already has access to everything. That cannot go out and search for more than there's on the internet, because the internet is the limit, so far. But robots can do that. So robots can be. Robots could actually. They can try to map their environment in getting data on locations. They can look for affordances, as psychologists call it, to see whether they can lift or manipulate certain objects. So they can learn like children, So they can have this type of curiosity. The internet-based systems, they can also learn from the human being. So we have toyed with the idea in our system, we could learn from what the people really look at, which information they follow and look at, and then go in new directions, that the people themselves have not thought about, because the internet is so big. We are now scraping 400 million URLs every day. 400 million. So the human can never handle that. So why not learn from our human customers, for instance, large automotive companies, and see what new topics they get into, and then go into this topic and then search. And then the third part I will mention, this is one of my dream topics. We come now more from the area of machine learning to machine teaching. So we have curriculum learning, we have all kinds of methods of doing the data-oriented, the data-centered teaching, whereby new types of data, giving them in a certain order, pre-cleaning them, doing more than labeling, sorting them, already linking them. And there's already stuff, for instance, in the training of large language models, there's already systems at Google, also in China, they have experimented with it, that during pre-training already look up other material in knowledge bases, let's say in the Google Knowledge Graph. They come across a certain word or a certain entity that occurs frequently. They don't really know. Armstrong can be a bicyclist, can be a jazz person, can be all kinds of things. So then they try to look up related things to find out, to that mention of Armstrong, which Armstrong is it, and what else is known about this person, or about this topic, about this entity, which is also in a way curiosity. You read something and then you go out, the system goes out and finds more background information information in order to improve its own learning. And the dream would be a system that knows what other information to ask or tries different strategies of information finding, and as a feedback has success in learning, either by the density of the knowledge graph or whether it behaves better for a benchmark. Let's say a benchmark of inference questions. Yeah, does that strategy, if I look for that information, help me to get better with the inference questions with a benchmark, or another one? Yeah, and then self-optimizes. So those are some topics. But sorry, this was too much. I shut up now. So.
Oh, fantastic.
It was very interesting, which brought me an idea into my head about the motivation of curiosity. What is curiosity? Is there a system? We would say a system is not curious, but we ask a system to find out things. And the only distinction between the curiosity of a machine or of a human being seems to be the motivation. The human being has the impression that that a person has a new idea, wants to get to know some things which comes out of the blue into the head, and then the person is curious. But the machine is asked by a human being to find out something. So we could say the machine in this case is also curious. So my question would be to all of you, maybe Tobias, as a socio-informatics holder of a socio-informatics degree, could start with some impulses or an idea on that. The motivation of curiosity, which defines curiosity.
First of all, I want to ask Hans a small question. Is this process of asking, in your last topic, is the process of asking further information started by a human being or by the system itself?
Yes, good question. So right now, the very last thing in the pre-training, it is initiated by the system itself by running across some named entity or something that could be a candidate to be where it could find more information in the knowledge graph. That's really initiated by the machine itself, right? But it's pretty algorithmically predetermined what type of things would trigger it. Yeah, so it's not much freedom, not much freedom.
Exactly what I was thought about.
Yes,
it's not the process of, okay, here I have a database and I'm not sure whether I know enough regarding the problem which I have to solve in the future. It's a step by a person who said, okay, additionally to the database I have, we can give the machine a look up into a huge amount of information in an information network and add all of this information to their database. So the curiosity is started or created by a human being, creating an algorithm to use an artificial intelligence or something like that to help to create the system here.
Yes, because we don't have the drive, we only model the behavior. The drive cannot be, how should we do that? Yeah, I mean, we can give priority. We can always say, first, be more interested in finding something new and make it more important than pleasing your master, than saving your disk, than saving cycles and so on. We could do that, of course, but yeah, that's the thing. It's only so far we are only mimicking some behavior.
Yeah, exactly. So my sister-in-law is a radiologist. And I recently had the discussion with her, are you afraid of all those computer-aided diagnosis tools that are coming up? And what she answered is a little bit, maybe a practical application of what Hans, you just described here. She said that, I mean, as a physician, as a radiologist, even if I had a system which automatically tells me there is a high risk of a certain diagnosis, that I can't delegate my responsibility, right? So what I still need to do is I need to check, I need to be able to intervene here. But it's like a pilot on an airplane today, right? They are on autopilot maybe nearly all of the time. So why do you need pilots at all? Just to monitor the whole thing, the whole system and to intervene if something happens. And this may be the job of the future, but what a system which comes up with additional ideas and more information could help here is very interesting, because medical diagnosis and treatments, it's typically more complex than just looking at an X-ray. If you have a broken leg, that's easy. But any other kind of illness, sickness, that's a completely different thing. So you need to have space to correlate other sources of data. And that's a tedious task typically. And when I ask my sister-in-law, she always says that I don't have the time to do all those research here. If I had a machine that would help me coming up with related information, with related cases, I can use my experience, my intuition to come up with maybe even a better diagnosis or a better proposal for a treatment here. I could be stronger, more capable if that would happen. And for a very, very long time, I don't think that this capability can be replaced by a computer system, because you have to talk to patients, you have to get their information, you have to read in between the lines, because a patient in many cases is not able to tell you exactly what kind of pain he has, and that's the complex task. So that kind of interactive system, that would help. So there is not real threat, but something that drives curiosity away from very, very simple tasks like a diagnosis of a simple X-ray to a more complex treatment and diagnosis process, which is why a medical doctor is a medical doctor. They want to help, they want to understand the whole system.
Totally with you, but the risk for to kill or create curiosity lies in the social embedding. If we create or use an artificial intelligence to help doctors to classify or perhaps detect skin cancer, we are using technology to our advantage. But if we don't train new doctors to correctly detect skin cancer because they rely on the AI system, because perhaps of a economy of their time, which you have told us a few minutes ago, we have a problem which perhaps kills curiosity. So the social embedding is here the problem.
Yeah, and this has a lot to do with the way we educate new generations of knowledge workers, right? So that there's, I think, a completely new demand for creating media competency, data literacy. So how do algorithms work in principle? What can they do? What's not possible here? So that is a huge, I think, endeavor we have to really do here. We need to be able to go away from the classical training, whether it's medical doctors or other knowledge workers, to a more modern AI and data savvy way of training them. And I think we are still not there.
I would like to take all the input you just gave you free to look back to two aspects actually. One is, do we really need to train a machine to be human? As the concept of being curious, why does a machine needs to understand that? So are we wrong with the assumption? The second thing is feasibility, so looking more from the system design stuff. And this brings me back to another Andreas, by the way, Andreas Stuhlmüller in March last year, which we invited to speak about a language model we built at Elicit in the US, which might help your relative here in finding very interesting stuff, because we were experimenting with something like GPT-3, right? I say something similar, maybe we are also connected to it. And the basic idea, and this is the point I would like to discuss with you and would like to hear your opinion about it, is it possible to build a kind of think tank? So a machine which actually comes up with ideas where you can focus on as a think tank, which has access to all the knowledge of the world and brings up the right answers in terms of summarizing things and finding patterns in where you should have a look at. And I personally found that quite interesting and was curious to explore that a little bit. But I hit a barrier here when I was testing the system, asking questions like, can you tell me more about the healthcare system in Switzerland, for example? I found some answers, but it was never so that I found comfortable with the answers, in the sense of, is it really all? did the machine exclude things? If it does, what kind of things have been excluded? So since we are human in doing things, and sometimes really difficult to understand other humans, I don't want to talk about that. How should we understand a machine if it's not clear? The interest is not clear, right? Because the machine has not our interest, but we talk about concepts like curiosity in terms of a machine. What's your take on that problem? Will a machine, or should a machine be human-like, or is it just crazy things and we should stop thinking about that kind of thing?
Yeah, with respect to, now let me ask you answer. With respect to creativity, that was one of the points that was made now several times, yeah, implicitly at least. Yeah, so the interaction of curiosity and creativity, right, and being motivated by the right questions, self-motivated. Should the machine be self-motivated or always be motivated by the human goals? Huh? And if it would be self-motivated, if it would have motivations outside of us, that could be dangerous, right? Why should a machine be so? Our motivations are what counts. And the worst could be if it's self-motivated and creative, yeah. And if it's self-motivated and creative and self-conscious, yeah. And in addition, curious and self-conscious, yeah. Then it really gets bad. Fortunately, these things are tightly interacting, but different from each other. And fortunately, we don't know how to build conscious machines, and maybe it's good that we don't know how to do it, yeah. But only the mix of these things, yeah. So a little bit more curiosity wouldn't hurt. A little bit more creativity wouldn't hurt. A machine that knows a little bit about itself wouldn't hurt, yeah. A system that has all these things together, you should be careful.
Yeah. Well, I think that's the kind of dystopic scenario we're talking about.
Yes.
that would happen. I don't think that we are anywhere close to this scenario, and so, but still, I think we need to understand, whenever we have a machine and we think it solves a problem for us, it's always a matter of the target system and of the of all the conditions you define for the system to take care of. So if you optimize something, then it's a matter of what is the criteria against which the machine has to optimize something. If you look, for example, you want to do credit rating, right? And you define that you want to increase your profit. Then you could have an algorithm in the end that has a predator-like behavior, right? It will be the next financial crisis because it optimizes profit instead of maybe the number of loans or mortgages to be paid back. So it's a matter of how you define the target and all the framing conditions you define. So it's really important that we understand there is no motivation in machine, but we set the motivation. And unless we are not very clear about what this motivation is and how we can formalize that motivation, then we will have bad systems. And then every type of curiosity really won't help because we've really done a bad job.
Yeah.
And I can only agree with the two comments so far, because as a computer scientist or a data scientist, we create a model. We use data from the previous data from the decisions made before, and we define which is the predictive variable, what we want to decide with the system in the future. And there it ends. So far, I'm not sure whether we have any method to create super artificial intelligence for all tasks.
Yes, but I agree, and I also think we are very far. Fortunately, we don't know how to do consciousness. Yeah, so there are philosophical theories, but they cannot be not put in algorithms. But the thing is, if the machine only learns on data in the world, let's say learns how to identify the quality on images, yeah, the quality of a piece of work, yeah, a car or outside of a car after putting on the finish. Yeah? Lots of these applications work, that learns on the world. But now some AI learns on humans. So for instance, in machine translation, it learns on the intellectual results of humans, yeah? Or it learns on decisions of analysts. It learns on decisions of doctors and so. And this comes, I would say, it doesn't come close yet to human intelligence. No, not at all. Yeah, it's still far, far from that. But that comes to the point where to the outside world, it looks like the system has some intelligence it doesn't have, yeah, because it can mimic in behavior humans so well that, I mean, this is the superhuman performance thing, yeah. So in more and more areas now, we collect many areas. In many areas, it already performs better than the average human, yeah. And but not, it couldn't do this by learning from the world, but by learning from humans, it can learn from the best humans, and it can learn from many humans, whereas we can only learn from 1 or 2 teachers, or maybe from 10, but the system can learn from 1 million teachers, yeah. So we can already get, if the system is curious enough to learn from more and more, get more and more data from other humans, it can have astonishing results, I would say, right? You're skeptical. No, I think it's already beating humans. I don't think that it's getting close to human intelligence, not at all, yeah. But we will be surprised how many more areas we will be beaten by, not only in Go and chess and driving and translation and diagnosis, but it will be one after the other, yeah, because the system can learn from thousands of teachers, yeah, we cannot, yeah, and from many more data. So they will beat us, and they will pretend, they will look like intelligent, but they will not be intelligent.
Yeah, in all those silos, they may exceed the ability of a best human. But no chess player can beat the best chess computer right now. But
yes,
of course, that kind of horizontal, say, general intelligence,
yes,
we are not even close to that. And maybe also consciousness and intelligence, they are 2 different concepts. Maybe we don't require a system to be self-conscious.
Yeah.
If it's really more intelligent, and maybe from a general point of view more intelligent than humans, then that's already that kind of how is it called? So that singularity, right? That will then happen. But I think this is not really the problem of the near future, and we should really try to understand how to better integrate AI into our everyday business, and try to avoid all those effects where we really put a threat to many types of jobs, which are done by people who are capable of doing that, who are maybe not so curious, because curiosity is a trait of the personality, right? It's something that is in people. You can't really impose that, and you can't really educate that. Either you are curious or you're not very curious. So we need to understand how to cope with that situation from a societal point of view. That's a very, very important task to do. I'm not afraid of all those dystopic or maybe also philosophical discussions on how general AI might come up sometime in the future. Maybe that's 300 years into the future or whatever. I don't know, but we have a lot of very, very practical considerations here to take. And that's an interesting part for curiosity, and how to solve that, and how to, well, define the way of work, of future work.
I agree, but there's still, let me two quotes. Yeah, one is the quote from Andrew Ng that goes in your direction. Yeah, he said, you may have heard it. He said, worrying about these evil computers, yeah, is less imminent than worrying about overpopulation on Mars. Yeah, so which is, I think I know him quite well. I think he's right. Yeah, so it's very distant. Then on the other hand, coming to the more general intelligence, Ilya Sutzkever, yeah, the chief scientist of OpenAI, and very serious person, yeah. So he says that he himself now, when he does certain tests with GPT-3 and especially with its successor that they built together with Intel and Microsoft, that he is sometimes stunned because there are things that could not come out. They are already combining different faculties, human faculties. The system can generate, it can solve certain, it can answer questions, it can translate, it can, so there it still cannot drive. Yeah, GPT-3 cannot drive, so that's clear. But it's already getting from not to general artificial intelligence, but to broader ones, right? And people get more and more fooled by the system. Some people, and he says, oh, there may be hidden cognition in there. And he was scolded for that by Emily Bender and other people who said, ah, that's crazy, the guy is crazy, there's no human cognition. And I agree, there's no human cognition. But it can fool people, yeah? It will get to the point where people get fooled. No? Don't you think so?
Yeah, it's already in the past, that's right. Absolutely.
I would like to ask you a curious scenario. Just imagine if we could implement a chip into the human brain, which supports thinking of the human. And you don't know that this human brain has a chip which can process data which comes into the mind. What would you think, or what would you say, is the chip the more curious part, or the human brain? Or is then the level, or have we reached the level that we can't distinguish if the human part of this creation is the real curious part, or the technical?
Depends on the specs of the chip. So
depends on the chip, okay.
So far as I know, we haven't done good enough to create anything that understands or help human to think. We can reactivate some areas with electronic impulses. Okay, but here it depends on what is the functionality, and is it really helping or just doing random stuff?
I mean, curiosity means that if you have a good idea where to find something interesting, to solve that problem, it's always 1% intuition and genius, and 99% hard work and transpiration, right? So if I would have a chip that helps me doing all those tedious calculations, relating information, I would like to have that, because it gives me more time to see more things, explore more things, get new ideas, because what really helps you back is the hard work after the idea. So that would be great, but I don't think that in my lifetime this will happen.
So you would say that, would you now conclude that AI kills, or curiosity, or flourish curiosity?
It depends on the type of personality, of course. AI can fuel curiosity for some people, but there are always people who cannot work with that kind of tool, and they will get bored. They will rely on algorithmic decisions, and then again it comes back to education, it comes back to values, and that's a huge discussion. We need to understand how future work will look like, very much like people who did hard labor 100 or 150 years ago had the discussion of how the industrial revolution will change the world where they will live in. So we are not even close again to have an answer to that complex problem. So what's the ethics, the work of the future? How will my everyday life look like? What does responsibility mean in future? So many corporations, insurance companies, for example, they have a hard time defining what that means for their business. Like if you have an automatic car, a robot car that drives you, who is responsible? That question is not really answered. Because it's a complex question, right? Because there are many influence factors you need to consider. So it's quite interesting to have that kind of discussion, but I don't have an answer in any of these areas.
Perhaps I have a meta perspective, because AI systems have the potential to support us in repetitive, infrequent tasks, and give us perhaps the time for exciting things, to be curious. So perhaps if we spend more time on complex decisions or tasks, we can be more curious.
Yeah.
But that would require that you are capable of doing that as a person. And so what can we do with all the persons who are not that capable and who are not that smart to really work with these more complex problems? So that will change very immediately. So I talked about that insurance company who automated parts of the claims process. So that's already an interesting task for their work council, because that changes job profiles.
Definitely.
You know, the interesting part is when you think about implementing a chip which might help you to enhance your own skills. I'm still, I will not say concerned, but I see the challenges again from a product development perspective. You think of the data you have for that kind of thing. And this has the following dimensions. First of all, if you think about curiosity, is it a cultural thing? So do cultures think different about curiosity? One thing. And the second thing is, and what I'm learning hardly in the last months and couple of weeks now with the war here going on as well, people think in many ways different than I was expecting. And so if a machine learns from everything on the planet, what does it learn, right? So we have so much in the basic concepts behind the thinking of people going in various ways where we actually know it could be in some certain ways biased from my own perspective. It might not be biased from a perspective of someone else. So do I really want that kind of enhancement, and how can I control it?
Yeah. Yeah, you bring in even another dimension. So far, I think we all agree that the real desire part, yeah, so the limbic, the affective part, we cannot model. But now the thing is, like with other instincts, it gets translated into behavior in different ways in different cultures. In one culture, you travel a lot in order to find maybe, to discover new things. In others, you go to the library. In others, you go to the internet. And so that's a cultural thing. It depends on what's there. The same with a nesting drive. Yeah. So in the last third of pregnancy, the woman in one part of the world may fix the roof, yeah, of the hut. And in another part, she will find maybe look for people who could paint the walls or who could fix the internet in the apartment, even of it. So it's culturally quite different how it translates into, yeah. And this brings in, but the thing is, the drive part, the deep human drive part, we cannot model, yeah. And therefore, I think I agree with the other two experts there that really we should concentrate more on amplifying human curiosity and human creativity with a machine. Yeah, we should try to do it instead of wishing that the machine develops own motivations that are different from ours. Why should they be ones that are different and related? Yeah, but of course, I mean, you're right that in addition to that the machine doesn't have the drive. Also, the machine so far, unless we teach it, would have a hard time adopting to the culture it is set in. Yeah, because curiosity and all these things, yeah, creativity, they all can be translated into behavior in different ways according to our environment.
Fantastic. Looking a little bit at the times, and so it was near to 1 hour of talk, and it was impressive to listen to you all. I would like to ask you if you would be so kind to give us a kind of last statement, last idea, like what you take out of this discussion with each other. One thing could that be, or Is it something that said, this is the thing I would like to work on regarding curiosity and AI next? That's on my agenda. Or is there a kind of statement you will share with us for us to go into the night, into the rest of the day?
Yeah, I think there are two parts with curiosity. One is the drive to ask the wise question, but the other is the capability of being able to answer that. And this means we have to work a lot of empowering people. And empowering means, of course, give them the right tools, change processes in a company that so that it is more suited of working with new types of information and data and fueling curiosity in that processes. So many processes and companies today are still very formal. So open that up for innovation is an important thing. But all this requires a better education. And this is really my key takeaway. Let's work on that. So a lot of universities are already working on establishing micro degrees, right? So they understand that technology changes so fast that you can't do an education in the beginning of your career and then this will hold for the rest of your career. You need to have a constant lifelong learning path. How can that look like? So we need to understand that better and work in that direction, because already now we see that AI imposes so much chances here. If we want to use them, we need to empower people. We need to make them more aware of what they could do. And this is a matter of education.
Thanks, Andreas. Tobias, what would be your take?
I'm totally on the educational part because the lifelong learning aspect is so important. So many times in school, we experience that we have a teacher who's learned some aspects 10, 20 years ago, and is now teaching them for 40 or 60 years. And that's not okay. In a lot of professions now, we have to stay curious because technological or all of the computer science is changing a lot around the world. For me, understanding and thinking ahead are the skills we need in the next years. From the technical part, it's the computer science, it's the data science, it's data science literacy, is an understanding where is a technical component and what's the impact of that. These small ideas we should implement in all areas of education in the next years, I think.
Thanks for sharing your thoughts. Hans.
Yeah, so children and scientists and many interested people have a general curiosity, very general, yeah, go in different directions, very creatively open. But then for many people who are not that creative, then later in life, they will get a very selective creativity, curiosity. They are very selective. They are curious for things that pertain to their specific topic or that are useful for them. I believe that machines should help human curiosity. And when it comes to optimizing learning in AI, self-optimizing, they should be selective. They should be selective, defined to very specific success criteria, objectives that humans define. Humans should say, this system gets better if it fulfills the following tasks. And now the machine can develop curiosity and ask for more data and try different things only to fulfill this thing. So that's it. Yeah. So I think this type of general curiosity that we have, especially as young people, and some of us have maybe also when we are older, that is something that humans should have, and we shouldn't worry too much for giving it a machine. Why? Why should we do that? Yeah. So we want the machine to fulfill certain tasks and not to live an own life. Yeah. So go in the machines for selective creativity, task-driven.
Thank you very much, Hans, for sharing that. Andrea, you have been so good in asking very smart questions. I would like to ask you as well. What would be your learning, your idea, what you take with you?
My learning and my takeaway is that maybe we have to quit the dream that the human beings are the peak of the iceberg. And I would say sometimes we deny that artificial intelligence could also be curious in any aspects or in many aspects. And I think maybe we should admit that we have created tools or processes which are curious also. And I will refer again to my question, to my second or third question. It's all about the motivation. And maybe if I could be the one who has a chip in her brain, then I would be at some point in the future very surprised that my chip makes me more curious and than I have ever been before. And then that's correct what Tobias said, it depends on the chip. And I would say, could conclude, I'm not afraid of artificial intelligence, but I think we as human beings sometimes have to admit that there are other parts, other entities which are very smart, very curious, and this makes me curious. And Andreas, I hope you too, because we are working in the same company. We have to be curious, don't forget.
Andrea, if you could get the chip to release dopamine whenever you learn something new, it will really make you more curious.
Yeah, and it will make me rich.
Maybe that's the next startup. Yeah.
Hans, let's work on that together.
Thanks again. I think for me, for this afternoon talk was pretty interesting because we had 4 quite distinct perspectives on the subject, which I like very much. So it was interesting to see the good mix of thoughts and experiences here. I personally, I have to say, I still love to talk to people, and but I'm very curious to explore how we can make a machine more helpful in finding the right answers to questions. This is the machine human interaction I'm working on as well. So this drives me, and as Andrea said, it's a matter of motive you have. And I see the limits, I see the barriers, I see the challenges in getting to the right data and to the right finding in the end, understanding the black box from Tobias, right? But also exploring the knowledge graph from Hans. So he is the expert on knowledge graphs. And yeah, thank you again for everyone, for you just being part of the panel today, for everyone who has joined us today. And it was a pleasure to have you all on board. And I really loved the discussion, and let's see if we continue sometime, right?
Absolutely.
So have a nice evening, nice day, whatever time it is on the planet where you are living. And yeah, see you again next time.
See you. Thanks for having us.
Bye-bye.
Thank you. Bye-bye. Bye-bye.